Vector atom model. Vector atom model is an extension of the Bohr and Sommerfeld atom model. Before we considering the vector atom model, we have to discuss about the drawbacks or limitations of Bohr atom model. First drawback is it could not explain the fine structure of a spectral lines. It could not explain the relative intensity of hydrogen spectra is the second drawback of Bohr atom model. Third one is it could not explain the Zeeman effect and Stark effect, in which the spectral lines could be split up under the influence of a magnetic field or electric field. To overcome all these objections, a new model of atomic model proposed that is known as vector atom model. The vector atom model basically deals with the total angular momentum of an atom, which results of the combination of orbital and spin angular momentum. The two distinct features of the vector atom model are: first one is the concept of spatial quantization. Second one is concept of spinning electron. Firstly, we have to discuss about spatial quantization. Spatial quantization. According to Bohr's theory, the orbits are quantized as regards as their magnitude only. But according to quantum theory, the direction or orientation of electrons orbits in space also should be quantized. To specify the orientation of the electron orbit in space, we need a fixed reference axis. The reference line is chosen as the direction of an external magnetic field that is applied to the atom. The different permitted orientation of an electron orbit are determined by the fact that the projections of the quantized orbits on the field direction must themselves be quantized. Second, spin of the electron. The electron spins about an axis of its own, while it also moves around the nucleus of the atom in its orbit. In other words, the electron is endowed with a spin motion and an orbital motion. According to the quantum theory, the spin of the electron also should be quantized. Hence, a new quantum number called the spin quantum number S is introduced. The spin endows the electron with a spin angular momentum and a spin magnetic momentum. Hence, the total angular momentum of an atom should be the vector sum of the orbital angular momentum and the spin angular momentum. Similarly, the total magnetic moment of an atom should be the vector sum of the orbital and spin magnetic moments. The orbital and spin motions are both quantized in magnitude and directions, according to the idea of spatial quantization. So, they are considered as quantized vectors. Hence, atom model based on these quantized vectors is called vector atom model. So, these are the base concepts that based on vector atom model. So, the next topic is quantum numbers. We have 7 number of quantum numbers: principal quantum number, orbital quantum number, the spin quantum number, the total angular momentum quantum number, the magnetic orbit quantum number, magnetic spin quantum number, magnetic total angular momentum quantum number. So the first 4 are basic quantum numbers and other 3 are derived quantum numbers. So we can consider each one in detail. The principal quantum number n describes the energy of an electron and the most probable distance of the electron from the nucleus. In other words, it refers to the size of the orbital and the energy level of an electron is placed in. The number of subshells describes the shape of the orbital. The serial number of the shells starting from the innermost is designated as its principal quantum number n. It can take only integral values excluding 0, that is n is equal to 1, 2, 3, 4, etc. The shells are designated as K, L, M. Thus, for n is equal to 1, the electron is in the first or K shell. For n is equal to 2, the electron is in the L shell. Therefore, n is equal to 3, it is in the M shell, and so on. The angular momentum of an electron in an orbit is always an integral multiple of h by 2 pi, that is nh by 2 pi, where the principal quantum number is represented as n. The second type of quantum number is orbital quantum number. It is represented by the letter L. The orbital quantum number. It must be less than the principal quantum number n, which corresponds to a shell of electrons. Thus, L divides each shell into n subshells consisting of all electrons of the same principal and orbital quantum numbers. This quantum number defines the shape of the orbital occupied by the electron and the orbital angular momentum of the electron. This may take any integral values, that is 0, 1, 2, etc. up to n minus 1. For example, thus, if n is equal to 4, one can take the 4 values of 0, 1, 2, 3, for which an electron L is equal to 0, it is called S electron. If L is equal to 1, it is called P electron, and so on. It is by considering L can have a total of n values. Thus, for n is equal to 1, L can have only one value that is equal to 0. For n is equal to 2, L can have two values, 0, that is 0 and 1. For n is equal to 3, L can have the values 0, 1 and 2 and so on. N gives the principal shell while L gives the possible orbital shapes or subshells. Thus, for n is equal to 2 and L is equal to 0, the electron is said to be moving in the 2s subshell. If n is equal to 3 and L is equal to 2, it is moving in the 3d subshell. The electron with orbital quantum number L is said to have an orbital angular momentum Pl, that is given by Pl is equal to Lh by 2 pi. The third quantum number is the spin quantum number. It is represented by the letter S. The spin quantum number describes the angular momentum of an electron. An electron spins around an axis and has both angular momentum and orbital angular momentum. Because angular momentum is a vector, the spin quantum number has both magnitude and direction. This has only one value, s is equal to 1 by 2, where s is equal to 1 by 2. Since the spin motion can be clockwise or anti-clockwise, s can be positive or negative, that is s is equal to 1 by 2 or s is equal to minus 1 by 2. Two electrons with the same sign of spin quantum number are said to have parallel spins. Two electrons with the opposite sign of spin quantum number are said to have opposite spin or paired spins. The spin angular momentum is given by Ps is equal to Sh by 2 pi. According to wave mechanics, Ps is equal to root of s into s plus 1 into h by 2 pi. The fourth quantum number is total angular momentum quantum number. It is represented by the letter J. It represents the total angular momentum of the electron. It is the sum of the orbital angular momentum and spin angular momentum. The vector j is defined by the equation j is equal to L plus S with the restrictions that is j is positive. The spin angular momentum S is equal to 1 by 2 or minus 1 by 2. J is equal to L plus S when S is parallel to L, and J is equal to L minus S when S is anti-parallel to L. Thus for L is equal to 2 and S is equal to 1 by 2, J can have the values 5 by 2 and 3 by 2. The total angular momentum of the electron is given by Pj. That is, Pj is equal to Jh by 2 pi. According to wave mechanics, Pj is equal to root of J into J plus L into H by 2 pi. The fifth quantum number is magnetic orbital quantum number. It is represented by the letters ML. The projection of the orbital quantum number L on the magnetic field direction is called the magnetic orbital quantum number. The possible values of magnetic orbital quantum number are L, L minus 1, L minus 2, etc. up to 0. Minus 1, minus 2 up to minus L. ML may have any of the 2L plus L values from minus 1 to plus 1 including 0. Sixth quantum number is magnetic spin quantum number. It is represented by the letters MS. This is the projection of the spin vector S along the direction of the magnetic field. The spin angular momentum S can assume only two possible positions with respect to the magnetic field. It may be the parallel to it or anti-parallel. Magnetic spin quantum number can have only two values, plus 1 by 2 or minus 1 by 2. The seventh quantum number is magnetic total angular momentum quantum number. It is represented by the letters Mj. This is the projection of total angular momentum vector j on the direction of the magnetic field. J can have only odd half integral values, that is, j is equal to 1 plus 1 by 2 or j is equal to 1 minus 1 by 2. Hence, Mj can have only 2j plus 1 values from plus j to minus j. 0 is excluded.